What's up, guy? What's up, Icarus? I hope you're having a fantastic Sunday. Oh, it's about that time. What's up, everybody? I hope everyone had a fantastic Sunday. I had a pretty good one. I'm a little crispy. Spent most of the day outside. We got to go to the track. It was fun, but I'm toasty. I am so toasty. And so, because of that, I put on my Red 5 shirt. So you wouldn't be able to tell. I hope you guys are having a great day. Make sure to tell your fathers Happy Father's Day. I had a pretty good one today. Actually, the kids were able to surprise me. They were. So I told y'all, I knew what they were getting me. At least I thought I knew what they were getting me. Because basically I could see what they were looking at in the Amazon cart. I didn't actually go look at the order. They got me something different. It was still a coffee cup, but it wasn't the one I thought it was. They got me a Super Mario Brothers coffee cup. And it's like the nighttime mode in Super Mario Brothers, and then when you put the hot water in, then it lights up and you see all the blocks and the stars in Mario, whatever. So it's kind of cool. They were excited. Agent Zero was so happy for me to finally open it. Pastor gave the dads church, gave medals to the dads at church. See, I don't know. I feel bad because I don't know what we did at my normal church last night because I went last night because the kids haven't been able to ride in over a month, and we just happened to be able to go today. So I was like, okay, I'll just have to go tomorrow night. This is the only time we're going to be able to go. So I don't know if they did anything special at my regular home parish. But yeah, it's typically, I remember one time though, they had like all the dads like get up and come over to like stand up at just at the front of the church, and like you saw like how empty the church was without it. So he used that as an example. It's like, hey, look, there's no one of us, like there's this huge group here that's like just sitting back there. The wives gave the medals. Oh, that's cool. Hey, Monkey, what's up, dude? Yeah, so we took the kiddos out to go riding today, and I took Honey Badger with me too. So Honey Badger's about, yeah, he's 4.5 right now, a little over, and he's getting ready to start riding too. But I wanted to get him start getting used to going out there some more, so I took him out there with me. He mostly played in the dirt, but he loved watching his brother and his cousin go around the track on their four-wheelers. My father-in-law and my nephew's dad, brother-in-law, sister-in-law's husband, I don't know, whatever. I just usually call him my brother-in-law. Anyway, he was out there too on his dirt bike. So they were on their dirt bikes over there following the kids around. Agent Zero had to relearn a couple hard lessons. Well, first he had a mechanical breakdown. Like his whole crankcase came off. Hang on. Let's see if I can find this. Yeah, here we go. That was his crankcase right there. His freaking. This wasn't his normal four-wheeler. This is another one that we had built up and we were going to test out and check it out. And yeah, he's riding around and we just see him stop and like, what happened? He's like, the engine broke. I'm like, what? Yeah, the freaking crankcase came off. So we went and checked it. All the bolts were missing. Like, I guess maybe they didn't get secured properly and they had vibrated out. And then there's one that's like up here at the top, the other counter side to this. It sheared off. So I guess 3 of them got lost and one of them just sheared. So thankfully, one of the other guys at the track had spare bolts. So we were able to get it back on there and he could keep riding. But poor kiddo. Hey, 57, what's up, man? Don't you think it's weird that there's an International Men's Day all over the world the same day, but women get to celebrate on different days all across the year depending on which country you're in? Dude, it's all... Oh, I don't know. I don't read too deeply into things like that. I don't know. I think that really kind of just more or less grew organically. I don't know. See, I don't know what the difference there is between like International Men's Day and Father's Day. I mean, I guess one is like obviously a subset of the other. Not every man is a father, so. Yeah, the dads have it together. Exactly. I have no idea, man. And I'm so brain cooked right now. I was still working on a YouTube video before the stream. After I get done, I gotta go pack because I'm leaving tomorrow, and then I'm gonna finish out recording the YouTube video. I can edit it while I'm on the road, but I gotta get that all going in there. It's gonna be a fun one. I think I told you all about it last night. It's the one about that really scrub tier Ethiopian hacker that was using Claude Code to do everything. Yeah, I got some fun stuff planned for that one. So I'm working on that, and I think I'm going to target Tuesdays or Thursdays for getting videos out. But unfortunately, if I don't get this recorded, there's no way I'm going to get it out and like ready for Tuesday, even if I'm heading it, like if I've got it going, what is this? If I've got it, where I can edit it on the road. That's not the big deal. But anyway, so yeah, so that's what we did today. We spent the whole day out at the track, and poor Sock, she messaged me today. She says, how do you get anything done? I'm so tired today and I have no motivation. And it's like, babe, that's my secret. I'm always tired. That's it. I do it out of habit. All right. So last night, actually, I got to tell y'all something real quick. I realized that last night, the stripe test actually had 3 parts to it. So we only did the first challenge. I went and knocked out the second and the third here. And I think they were actually easier than the first one in here. But they were pretty decent. So we're still doing the white belt. We are now at stripe 3 for white belt. How do you trick people into not noticing you're high? You just stay high. It's like, you were high? I thought that was just your default mode. Yeah, it's kind of like that. It's like, how do you know? I didn't realize how tired you were. It's like, I'm always tired. All right, let's see here. Let's dive back in because I'm actually having a lot of fun with this one. So, oh, let me go. Hang on one second. Let me go pin this over in the chat real quick. There we go. Let's see. Can I pin it from here? I think I can. I can't. That is a fail. Hang on one second. I gotta restart the kick stream real fast. Because it is just chug-a-lugging right along. It's not actually flowing properly. There we go. That should hopefully fix it over on the kick side. But yeah, so we're going through this cool little learning thing called binary Jiu-Jitsu. And it's been really fun. I liked it. So the next thing we're at, we finished stripes 1 and 2 last night. We're on stripe 3. Code auditing. Why is this thing still breaking? Killing me, Smalls. There we go. Hang on. I got to go check something now because that broke on me. Let me see. Did that fix it or not? I thought it fixed it. All right, I think it's back up. Cool. All right, let's see here. So we're looking at source code auditing. So some of the common patterns you would look at for looking at vulnerabilities is no bounds checking on input size. Now that was what we saw last night, right? We noticed that, hey, by the way, we have a set size buffer, but it can read an arbitrary length, right? Have I seen the Unreal MCP? No, what's that, guy? I has not seen that. I mean, unless it's like something like the Unreal Engine. They got an MCP. Oh, wait. Yeah, didn't they announce an Unreal MCP server? Yeah, I think I saw that. Yeah, they plugged Claude into Unreal Engine. Unreal Engine 5.8 introduced official experimental MCP server support via the built-in Unreal MCP plugin, enabling AI agents to control the engine through natural language. So is this... did they open the source code up for it? Well, actually, it doesn't really matter. An MCP server is a very natural protocol, right? It's a natural protocol. It's a well-defined protocol for the most part. So you can basically go ask it for all the tools that are in there and figure out like kind of what it's doing. So even if they didn't document it very interesting or very well, it's got some other stuff. Let's see. Also, apparently there's a lot of community developed MCP servers that have been done there. So there's one that is a TypeScript one. Oh, that's pretty cool. Unreal MCP. So this has been done before. I did hear about it, guy. I just brain farted on it. Spent too much time out in the heat today. But it looks like other people have already been like, hey, we're going to do this. And now finally Unreal's like, hey, we're going to do this ourselves. All right. So coming back over to here. So some of the vulnerabilities we might be looking for in source code is, like I said, no bounds checking on input size, trusting the caller to provide a safe input. So no... Hey, Gumby. What's up, dude? You're so full of crap. Trusting the caller to provide safe input. No, you could get unsanitized inputs. Or writing to destinations without knowing the size. So certain unsafe functions in C are gets, which reads input with no size limit. Shut up, baby, I know it. String copy, which copies a string with no size limit, or scanf, with the %s it reads with no size limit. And also, let's see, string cat, which appends a string with no size limit. I think you're noticing the pattern here. And fgets, which is safer than gets, but worth noting. What am I doing? I'm about to go murder some chickens. Actually, the chickens are being really dumb back there. I'm about to say, I'm going to cull you all and just start with a fresh brood. Hello, children. Hi, chef. All right, so finding these vulnerabilities. So find where a user-controlled input enters the program, trace the inputs through the control flow, look for unsafe function handling, check the fixed-sized buffers near those functions, and look for missing or insufficient size validation. So this vulnerable example, which is very similar to like what we had earlier, so what they've done is they defined a variable-sized buffer here, right? Or a fixed-size buffer. It's only 64 bytes long, but the gets command, the gets function has no limit on like how much data you can pack in there. So you have to remember, this is space allocated on the stack, and then gets is going to start cramming data into here. And if we send more than 64 bytes, it's going to start overrunning other stuff on the stack. Let's see. This is going to be basically allowing attackers to smash the stack and overwrite important things such as local variables, base pointer addresses, and the return address. So here we say like void vulnerable happens here, and then int main, it calls it with argv1. Yeah, pretty straightforward example. Actually, I take it back. Sorry, this is a string copy example. So our vulnerable one here has a char of 64 bits, right? And then we string copy from buffer to input. I forget if this is destination source. But anyway, basically copying between these two memory locations and then putting it in here. In fact, the way it looks like, because you're referencing buff here, this has to be destination source in there. I can't remember. It's been a long time since I did C also. So string copy was used to copy data from the command line argument to a 64-byte buffer, but notice it doesn't bounds the check. So again, the main thing here is unchecked size operations whenever they're moving back and forth. Let's see. Here's another example where we put hello in there, and then we string copy our input over into buffer, and then same thing here though. We're still using that string copy. So this example seems to be checking the input size of scanf. Oh, I mean, it looks like it, but really this is just saying like the first 64 strings. It then string cats up to, oh, hold on, let's see here. So this example seems to be checking the input size of the in the scanf, but when it passes the name variable to the vulnerable function, it then does a string cat up to 63 bytes plus a null byte into a 64-bit buffer that already contains 7 bytes of data. Right? So you can overflow by about 7 bytes here. So in most cases, the user likely wouldn't notice the bug as most people's names aren't 57 bytes long, but this would result in overflow on the stack. Let's see, here's another example. Enter your name, we do fgets. Sometimes developers make mistakes, perhaps a buffer gets used in multiple places and once was a different size, but during a refactor, one of the functions handling that data wasn't updated. So that's a prime example of why developers shouldn't use magic values and also use size F, because then you can tell exactly, hey, what's the size of this area to go move in here? Hey, Carson, what's up, dude? Oh, let's see. Code review. Let's go check it out. I really like this. This binary jiu-jitsu. I don't know. Maybe we'll stay on this for a little bit. We'll see. You guys let me know. Because if it gets boring, or it's like, I don't understand what's happening here, then maybe we'll switch off to something else. I'm digging it, though. All right, so what we've got in here is a failure to buffer allocate. All right, so we've got a name buffer, or a name array, a message array, and a config array. These are all defined by these what is this? Macros up at the top. I forget the exact term. These are basically like predefined functions, predefined links in here. So we have max name, max message, and then we got our config. All right, so then we call store username. It's gonna come up here. You know, I'm reading the code before I even answer the questions. You lost me at buffer, Daddy Blaise. Damn it, Gumby. Damn it, Gumby. Let's see. Just know that a buffer is something you want to overflow. Giggity. All right, so the first question is, which function is vulnerable to a buffer overflow? Well, let's go see here. So first thing it does is it calls store username. So let's look at that one. This one does a scanf. Extra J joke, that's right. Hey, Hats, what's up, dude? How do you do, fellow feds? I look buffer, bro. It's because I had to go take a shower after we were at the track, and so like my beard is in top form right now. I also trimmed it up a bit because it was getting a little bit caveman-y. But yeah, dude, the track is hella dusty. Freaking Honey Badger just looked like a little dust ball. We got in the house. I'm like, don't touch anything. Strip naked, go to shower. Don't touch anything. He just, I swear, he must have just rolled around in the dirt. I don't know how he got so dusty. All right, let's see. So in here, so we're taking a pointer over to buff. We're taking whatever this buffer here is. So we're storing the username in name here. And that's our max name size. I wish I could edit this. Let's see. Max name is 64 bytes. And then we're going to printf for a message. And then we're going to read the message from the message buffer here, which I don't think we've got any, but let's go see. So read message. Does an fgets of max message from standard in. Let's see, and then we do a config copy, config and default, or copy config. So what does copy config do? So copy config does a string copy to our destination. So what's our destination in here? Destination is our config. Our config is configured with a size of 64 in here. So that's the one right there. Config copy. Because it is using max name. It's using max name -1. Let me see. Actually, I take that back. Nope, that one actually looks okay. I think the problem here is record. Yeah. So log entry has it. Because notice how records is 64. It's 64 bytes, which is the name of... What is that? It's the size of the name in here, but this was the example they just gave us. We have, what is that? That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's going to overflow it by 12 bytes. Because we're copying a buffer that's that same size, but we've got that buffer size plus all this preamble in here. So log entry is actually the one that's got it in here. Let's see. So the string copy from record to username, that's the one. Ta-da! That was it? Just the one question? Okay. Easy peasy, lemon squeezy. We've done lots of code review on the stream. Let's see. Now, unfortunately, like I said, this is the one bug in binary jiu-jitsu that could be annoying. Notice how we cleared it and it didn't unlock the next one. So what you have to do is go back into the challenge and then just back out of it, and then it will unlock the second one. Oh, it's an extra dad joke day. I got you, Rabbit. Yes, extra dad joke today. Oh, thanks, Gumby. Yeah, I mean, there are way worse days to spend a Father's Day than out at the track with the kiddos. It was fun. Honey Badger was there. I think the next time we get to go to the track, which we get this like Godzilla level, what is it? Threat level God style El Nino happening. That's what everybody's been talking about. I haven't actually looked into it, And so it's just completely messed up all of our plans for riding this summer. So that's why we had to get to go today. But we did that. So I told Honey Badger, I was like, dude, if you keep showing me that you can listen, then bro, we will get you, we'll bring out the four-wheeler for you to start riding next time. The best coder on Twitch is live again? Wait. Theo's live right now? I need somebody to clip that and send it over to Primogen just to tweak his nipples. Hey, Ben, what's up? I am nowhere even close to the best coder on Twitch. Even the folks that are just sitting there doing nothing but leak code challenges could probably like code circles around me. I don't know. It depends on what we're doing, how they're doing it, you know. Hold on, what is this? Oh, daily challenge. I'm good with that. All right, so let's look at something real quick here. Cross-referencing the C code with the disassembly. So being able to make sense of what you're seeing in source code or later decompilation and what is happening in the assembly is important. So let's walk through a binary and understand what the compiler has done to the source to make it executable. So we got a very basic program here. This program says int main and then call vulnerable. Vulnerable has a classic buffer overflow. We have a 64-byte buffer, but we have unlimited execution here. And then we have a win function here. So what you'd want to do, like if you were executing this and the goal was to execute the win function, then you would come in here and you'd craft a buffer overflow that would come in and overwrite this, and then eventually smash the stack down to cover EIP, and then have it go jump up to the instructions in the win buffer. That's what you would do. So we're going to reference this throughout our thought experiment. So scroll back and forth as needed to understand what's happening under the hood. Essentially, the main function calls vulnerable. The vulnerable function prompts the user to enter a name into a 64-byte buffer. Unbounded gets is used to retrieve the user input. The function echoes the player's name back in a printf. In a normal condition, the function then returns back to main and the program exits. Real simple. There's no such thing as a best coder. I've seen so many examples of very good PC coders making absolute clown shows of bare metal embedded projects. That's what I was talking about. It's like somebody could be very good at front-end development and just absolutely hate themselves, or they could be very good at back-end development and have no social life. It just depends, right? It just depends. Or they could be game developers and probably just be completely constantly sleep deprived. Let's see. All right, so we're talking about here, it used an unbounded gets. We'd smash the stack if we did this. So here's the disassembly for the main function. Main is pretty easy. Main establishes its own extended base pointer. ESP, though, gets ANDed against here. So we're just going to keep like the last couple bytes. And then we're going to call the vulnerable function. So we call vulnerable. It jumps over to that memory address. Let's see. We see the prologue with our push and move operations. There's no local variables, so we don't see a subtraction from ESP. But we see this and instruction. This is to maintain the stack alignment, as the stack must be 16-byte aligned. They haven't mentioned that before. I remember reading that way back in the day, but they hadn't mentioned it before. So there's a call. Then there's a call to vulnerable. The address immediately after the instruction, is pushed onto the stack as the return address, and the address for vulnerable, which is that 919F, is loaded into EIP and the function begins execution there. So here's the decompilation of vulnerable. Or they can do web dev. Oh wait, that's the designers. And dodge bullet. That's right. If you can dodge a wrench, you can dodge a ball. Let's see. I guess I never realized that the stack had to be 16-byte aligned. Hang on, let me look somewhere quick. So for vulnerable, we're going to allocate this, right? And we're not taking any inputs. So it shouldn't have like a sub ESP yet. It's going to do a sub ESP for 64 here. And then it's going to call that gets buffer. So it's going to do a sub, it's going to call printf, it's going to call gets, and it's going to move some data around, and then we're going to call another printf. Let's see. So we allocate 72 bytes for some reason. Why is it 72 bytes? Hold on. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Why is it allocating 72 bytes instead of 64? That bugs me. Anyway, but here, yeah. So we see it allocating 72 bytes and then aligning the stack. This is going to be a push to basically the printf function. Or so actually, no, I take that back. It's going to push this onto the stack. So it's pushing enter your name into the string address here. Then we call printf. Then we clean up the stack. We align the stack. We go through and load address of the buffer. Oh, okay. So it's going to take the load effective address of EBP minus 48 and then load that over to EAX, push that buffer onto the stack. So it's allocating space for the variable. Then it's going to, actually, hold on, that's really interesting because look, up here, we have the space allocated here, right? But in the code, we actually, okay, no, so here's where it got allocated, but then it's actually getting the address of that. So we allocated it to here, but we got the effective address here. Load effective address of that reference there. Then called gets. And then it cleans up the stack. We then load the buffer address, push the buffer onto the stack. And then we say, okay, we're pushing it back onto the stack so that it's basically a what is it? It's an argument into the next function when we do that. And then we call back. Okay. So controls passed to vulnerable from main. We see another function prologue and a second stack frame is built. This is the second sub creating additional space on the stack despite not needing it. This is to make sure the stack stays 16-byte aligned. Oh, that's why. Hold on. 64 divides evenly into 16 though. Because up here it said it allocated 72 bytes. 72 does not divide into 16. Wait. Oh, I got it. In programmer mode, it doesn't give you the return to it. I'm an idiot. Divided by 16. Yeah, that's 4. 72 divided by 16 is fractional. So hold on. Why is it? They haven't really talked about stack alignment until this one. But basically it says there's a second sub creating additional space on the stack despite not needing it. This is to make sure the stack stays 16-byte aligned. Remember, 64 bytes plus 4 bytes for the base pointer means we need another 12 bytes to maintain 16-byte alignment. Oh, I should have just read more. Then they'd talk about it. Okay, so we needed 64 bytes for the buffer in the C code, right? But then we also had a base pointer in here. So we know where to like return EBP2. In fact, I think I still have that up. Hang on. Yeah. So EBP gets allocated here. So we need 4 bytes for that, like no matter what. And then we needed 64, but that didn't align properly. So then we needed another 12 bytes to make it align correctly for, in 16-byte chunks. All right. So then we see the address string gets pushed for the parameters for printf. That's a repeat pattern. load effect, let's see, we can see that the address for the local buffer variable, it gets pushed to the stack. And so that's the effective address here. So we load that, then we push it. And that passes basically that over to gets. So that way gets takes that as an argument, knows where to put it on the stack. And then finally, a leave and a ret. All right, we're good. And then wins is its own thing right here. So eventually we'll be jumping to here by overriding the return address on the stack to point to the address of win, which is here. So if we ever have like a static address like this, then what they're doing is they're not using address space layout randomization, but that's a much more advanced thing to try and figure out like where offsets are in a program. So if you have ASLR on, you'll never have these kind of hard-coded addresses. If you look way back in like some of the older buffer exploits, you'll see these kind of hard-coded addresses and they'll say, this works on like Windows XP for this vulnerable version of the program. And it's because it constantly allocated that program into the virtual memory at that memory address every time. So the key takeaways are is the compiler adds instructions that don't appear in the source code, alignments and adjustments and register saves, a stack cleanup are all compiler generated. Function arguments are pushed onto the stack immediately before the call, and local variables are accessed via negative offsets from the base pointer in there. Boop. And never move regardless of where ESP is. Okay. Got it. All right, so let's go look at this one. The prologue. I like this. This is a lot of fun. So examine the disassembly of vulnerable in the disassembler tab and cross-reference it with the source code. Answer the question about what the compiler generated in the function prologue. So for vulnerable, we have a 64-byte array that we're going to put in there. Then we got a function call. Then we got a get, and then we got another a printf, a gets, and then a printf in here. So the prologue comes in here and says, I'm going to push the base pointer in, and then I'm going to swap, basically move ESP over into the base pointer, and then we're going to subtract 48, 0x48. Hold on, what is 48 again? I closed the calculator. We go back over to programming. So hold on, what is 48 in hex? That's 72 in decimal. Okay, which tracks with what we were just talking about. So they're keeping it 16-byte aligned, and then they're going to subtract another C from here. This is C. C's 12, that's right. So why did they take out another 12 in here? So buffer is declared as a 64-bit char. How many bytes does the first ESP instruction allocate onto the stack? Oh, well, we just looked at that. It allocates, was it 72? Awesome. So the compiler rounded up from 64 bytes to maintain stack alignment because we needed 4 bytes. So to walk through what happened here is, for the stack alignment, we needed 4 bytes for the base pointer address, and then we needed another 64 bytes on top of that. So 64 plus 4 gives us 68, but it has to go in 16 byte chunks, so then it gets rounded up to 72. There we go. Wait, hold on. The extra 8 bytes are padded? I thought it was because we needed 64 plus the 4 bytes for the pointer address. Thought that was it. All right. Anyway, we're on the right idea. All right, so now it says examine the disassembly of vulnerable in the disassembler tab. Answer the question about the function prologue. Okay. So leave is a single instruction that replaces 2 instructions from the standard epilogue. Which are those 2 instructions? Enter them separated by semicolons. Let's see. What's it going to do for the function prologue? Well, it's got to move. If we go back over to our diagram, right? What's going to happen here is we've got to reset ESP and EBP. So what we're going to do is we're going to set and EBP's on the stack right here, right? So what we'll do is we're going to move EBP. We're going to move two EBP from ESP. So that should be the first one in there. Let's see. So we'll do move EBP, ESP. And then the second one we're going to do is going to be like pop to ESP. No. Pop EBP. That's not it. Damn it. That should have been it though, right? Those are the two that we got to do. Hold on. Yeah, because the return is after that. So the leave is a single instruction that replaces two instructions from the standard epilogue. What are those two instructions? Enter them separate. I thought I got that right. Right, Gumby, but I thought there was another 4 bytes in there when we were looking at that. So I was thinking 68 to 72, not 64 to 72. That's where I was going with it, because I thought it was accounting for the return address that was already on the buffer. A lot of this, they're getting pretty accurate on it, but you can tell there's a little bit where the edges have been softened from part of the learning experience. And so, now continuing with the 16-byte alignment, though, overall, I think they're doing a fantastic job with this. Have I installed Hermes Desktop yet? Hell no. Hell no. Hell no. To the no, 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 no. Hell to the no. I'm still tinkering with Hermes. I haven't really messed around with it too much, guy. Let's see here. It's a good thing to have. I mean, don't get me wrong. I will go test it. I have just been very, very busy with everything, especially having to go through and get ready to go travel pretty soon. All right. I wish it hadn't deleted my answer in here. That was kind of a dick move. All right, so we're going to move to EBP. EBP from ESP. We're going to swap those around, and then we should be able to pop EBP. I thought that was it. Because the extended base pointer should be pointing to where the old EBP was in here. Oh, you know what? I just realized. Oh, what is that? Damn it. I think that's not correct. Yeah, that's not correct. So the old EBP is in there. I think we're going to do another move. I think it's the second move in here. Is that it? Damn it, I forget what it is. I gotta remember what this is. Oh, did you bring me tea?
Yeah.
Awesome. Oh, that's really freaking hot.
It's really fresh.
Yes, it is. Ow. By the way, guys, this is the cup that the kids got me for Father's Day. Check that out.
So excited.
They were amazingly excited for me to try it. I was like, kids, I'm not drinking very much hot today. They said hi, son.
Hi, audience.
I love it too. This was not the cup I was expecting, but you know what? They were so excited about it, which makes me really like it.
It's not the cup I would have picked.
I know. She had awesome cups picked out, but the boys were like, "No, Daddy needs a Mario cup." I'm like, "All right, cool." Hold on, let me make sure I got this correct in here. Let me look at my diagram again. So we want to, this is our new EBP, right? This became ESP then. So I think what we wanted to do was move. Oh wait, was I doing this backwards? Oh, I was. We want to move to ESP. We want to move EBP over into ESP. And then we want to pop EBP. I had them swapped. I think that's correct. Ta-da! There we go. That Mario Cup's fire. I know, dude. They were so excited about it. They were really sad when the Star Wars mug broke because they liked seeing the lightsabers light up. And Honey Badger, he's just the right height where like his eyes kind of look over the countertop in the kitchen. So when I'd put something like hot water or coffee or something in that cup, he would just be there. He's just watching it. He's like, I want to see the lightsabers light up. They're so damn funny. Oh, we're getting into GDB. GDB. As I like to call it. GDB. At least you didn't. Be thankful you didn't receive a necktie you'd never wear, dude. I never wear a necktie ever. I think the last time I wore one was like Easter, because one of my friends was being baptized, and so like I did put on a full suit for that. And the time before that, it had to have been more than a year. Well, maybe not, because my dad passed away last May, so it would have been, I think, for that. But still, before any of that stuff happened, it was like years. I was years and years between wearing a tie. Years. All right. I have not been in the GNU Burger in a long time. Welcome to the GNU Burger, home of the GNU Burger. Can I take your order? That's gonna be stuck in my head all the time. All right. So this is a debugging application we can use to observe memory and registers during runtime, and we can step through instructions one at a time and see how the application under test runs and test theories that we may have about the behavior of the application during static analysis. Debugging is creative use of the commands below to find information about the application. I love the way they said that. Debugging is creative use of these commands. So we may want to set a breakpoint at a specific spot so we can observe a comparison or view something being loaded into memory from an external source. Like maybe over a network or something. Also, Dumas and Talisman, what's up guys? Welcome in and happy Sunday. Hope everybody's having a fantastic Sunday, a stupendous Sunday, a superlicious Sunday. I had a pretty good one. All right, let's see here. All right, so a couple of the commands we can use in GDB. We can use run, info, proc mappings to show memory mappings. We can set breakpoints. So you can set them like at function names, or you can break them at addresses. You can also see what they are. We can delete them or enable them. Or we can delete them or disable and enable. We can turn them on and off. And we have stepping and registers. There's a whole slew of commands you can do in here. This is honestly not something I recommend memorizing if you want to get into debugging. Just know that you're going to need a good cheat sheet. You want to go through and read through this in the beginning, so that way you can look at it and be like, okay, I need to know the functionality, and then I'll go take a look at it later. Yeah, that's right. We're debugging with propane and propane accessories. I hate suits so much. I told him, don't put me in one in a coffin. I'll live forever just to try to escape it. Maybe I can add some axolotl genes for immortality. I have no idea, man. All I know is I axolotl questions. All right, so we can get information on the registers. We can also examine memory. So this right here would say, hey, give me 16 words starting at where the memory address ESP points to. Give me 32 bytes at ESP, things like this. And then we can also look at the stack frame. So backtrace will show the call stack. Frame 2 will switch to frame 2. So, okay, so the debugger is actually tracking like where all those stack frames are. That's pretty sick. We can get info on the local frame, the local variables, and what the function arguments were. We also have disassembly commands, and then we have some pwn dbg extras. So get a context dump, check the binary protections, get a memory map, whatever the GOT table is. Is that the global exports? I'm not sure. Feds on YouTube. Oh, no, Zors. That's right. Everybody in chat's a Fed. By the way, if you didn't know that, it's your first time here, congratulations, you're now a Fed. You're going to want me to go through the GDB challenge? Damn it. All right. I know this was coming. We got to figure it out. Let's see. All right. So first thing it wants us to do is submit the flag. BJJ. That's funny. All right. So here's our code. We have load flag, and it's going to open flag.txt. Shut up, baby. I know it. That's right. It's the federales. All right. So what are we supposed to do here? Let's see. We do set vbuff, and then we do load flag. Load flag is a 64 character thing in here. Well, I mean, if we load this in here, oh, okay, so here's how we're going to get this, right? So what happens is the flag gets allocated buffer space, and then we do a file read operation. We read that into a pointer going to F, and then we open this as a pointer here to F, and we say if basically F exists, then we're going to get everything from into flag, the size of flag, which is 64, and we're going to read basically 64 bytes from flag here. And then we're going to do an F close. F, it never prints it out. So what we need to do is we need to actually we want to watch this memory region here where the flag variable is, and we want to break after we actually do the F close function. So if we go to the debugger, no such container. Unacceptable. Let's reset this. Everything, it's really cool because everything in here is happening inside of Docker containers. So I think it's pretty sick. All right. Give me the debugger. Give me the debugger. All right. Now I got to remember what the hell to do. All right. So run will start the program. So breakpoints, what we could do is we could do a breakpoint on load flag. So let's start there. Let's do breakpoint. Oh, it's not breakpoint. It's just break. My bad. My bad. Right here. So break on load flag. Oh, I'm cooked. There we go. Breakpoint set here. Now, the part of the reason why this is working, sometimes like where you can say, hey, break on load flag. I think typically to do that over in like GDB, you need to have the source code for it as well. Or you've gone through and you've done decompilation and you've kind of like named the variable so you can have something to map back and forth to. So now, if we run, then we're going to start seeing what we've got. Reconnect? Oh no! No! Damn it! I busted it. All right, so let's break on load flag. Actually, you know what? I think we could do something different here. Where was that? Where's our break? info breakpoints. Let's see. All right, hold on. Disable number 1. And then let's see if we can break on... Let's see if we can break on F close. Break on F close. Entry point set there. Boom. So now what should happen is this will basically, if we break here, we run the program, this file here will be the contents of this flag right here. So now if we go through it, run. Peaches. Peaches. Hey, puppy. Did mama let you in? Did mama let you in? Yes. Yes. This is the first place she runs to when I'm in the office. Like when she gets let in from outside, she immediately just runs this way. And so I hear her come. I don't know if you guys can hear it on the stream, but she comes barreling in here, like stomping her paws into the carpet. Oh, yeah. Not sponsored by Jocko yet. All right, so now what we want to do is we want to go look at... You okay, Peaches? Don't get your snortle stuck. Don't get a snortle stuck. Because she's got that short little snout, she'll get that, you know, like sound that short snout dogs do. Like pugs are real bad about getting it. Call that a snortle. She gets a snortle stuck in her throat. All right, let's see here. So what we want to do is we now want to go check a memory address. Hang on, I got to remember how to do that. So we get step through here, registers, let's see, stack information. There we go. Info on the frame. So we want to get the current frame info. Let's go check that. So info frame. Boop. All right, so here's our EIP address. So actually, we're currently in F-close. So unfortunately, we actually want to get out of F-close. We want to see if we can back it up. Can we step backwards? Back? I don't know what that did. Info frame. Do we get the same info? So before here, where was EIP? EIP was in F close. Okay, we're still in F close. All this is still identical in here. You know what's hilarious? 57. Did you see the name of that procedurally generated clip you just sent? It's tardy tired. I'm very tardy and very tired. Extra tardy even. You see how smooth this head is? Extra tardy. Let's see. Damn, so what I want to do is I want to step back. Actually, hold on. There's another way we can do this. We can go and we can do a backtrace to call the call stack. We can also switch frames in here. But how do I get a list of the frames? Info frame shows the current one. Local variables, argument functions. Let's see. Hold on. GDB list stack frames. What's the command to do that? Oh, backtrace does. I'm an idiot. It literally said it right here. Backtrace. Show the call stack. All right, so let's go. Let's do that real quick. So backtrace right here. All right, so we can then get info on one of those, right? We can say which frame we want to get info on. So we can now say frame. Let's see, load flag. So frame 1 right here. And then we can do info frame. And what was it to get the local variables? Info locals. Go figure. So info locals. Los locos kick your ass. All right. So here is our flag right there. Boop, boop. Ta-da! And so remember, if we look at the source code, This was a defined buffer that was going to be in here, so it was always going to be allocated onto the stack. So because of that, we could just go right over to it. So there is our flag right there. So let me do a little bit of copy pasta. Submit. Yeah, let's go.
Yo, Laser Lips, your mama was a snowblower.
I forgot about that insult monkey. Oh, I love those movies. I'm still freaking mind blown from Griffin last night telling me that Fisher Stevens was Ben Javari. Bro, he did such a good job. He did such a good job. I'm still mind blown by that. Hang on. Hang on 1 second. I had to text my brother. Because I don't think he even knows that. Hey man, did you know Fisher Stevens was Ben Javari in Short Circuit? That was one of our favorite movies as kids. My brother, Jude. I hope he didn't know that so I could blow his damn mind.
Your mama was a snowblower.
Oh, too funny. Oh wait, didn't we? We just did this. We passed it. Damn it. Go back and do it. Let me load it back up. There we go. Start challenge. I still have it copied. I wonder if it would work. Ah, I didn't. Okay. You know what? That's fine. Actually, I'm going to run through this again. Let's do this. So let's break on F close, and let's run this. And then let's go to backtrace. And then what we're going to do is we're going to switch over to frame number 1, and then we're going to do info locals. Right here, get some info 411 on the locals, and then bam! Right there. Gucci. I'm going to do this one twice just to make sure it really is done. I have to click that like 30 times to come up. There we go. All right, now we're doing some seg fault analysis. Nice. Nice. I wonder if they're going to have you go through and do... God, what was it? Hang on. I gotta remember the name of it. It's the tool from Metasploit that lets you generate buffer overflow patterns. Oh, it was just pattern create. It didn't have like a special name. That's what it was, just pattern create. I wonder if they're gonna have us go through that. All right, so now we're talking about seg fault analysis. So crashes are a great way to indicate an application has a potential vulnerability. So if you suspect a binary is vulnerable to a buffer overflow, you can opt to manually fuzz the application by providing a large amount of large input to solicit a crash. And if the application crashes, you may be able to exploit it. There's some gotchas in there, but that was the general way that this was done for a long time. Let's see. So take for our example our vulnerable function with gets, writing to a fixed length buffer, boop. So we would start by overwriting things on the stack. In this case, the next thing on the stack would be the saved EBP from the previous stack frame, followed by the return address. So if we corrupt either of these values, the program would crash. So let's suppose we sent 100 A's into the buffer. What's going to happen? EBP right here at that offset now points to here. So what happens when the function goes and to return? Remember, in the function epilogue, which is leave and then a return, first, ESP would be rebased to the pointer address. Then the next value on the stack would be popped over into EBP. All of a sudden, I've got hiccups. And I don't like this. Anyway, so what happens now is EBP contains the value of just 41, 41, 41. That's all A's in ASCII. And finally, the return address structure would pop off the next value of the stack and place that into EIP. So EIP would point to 41, 41, 41, 41. The application would then jump to that and attempt to execute any code there, but there's probably not any code. So it's likely not even mapped, and that's where the crash would occur. So it's going into an unmapped memory region. So finding the crash offset. So the next step in determining visibility of an exploit in the structures, we need to prove we can write whatever value we want into EIP. So in order to do this, we need to know how many bytes we need to overwrite before we're able to reliably control what was written to the stack and eventually pop it into EIP. So as we're writing stuff into the stack, right before it crashes, we want to get a memory address to something that we've written, right? So essentially what we're going to do, let's see if I can draw this from memory. Let's come down here. So as we come through and we start smashing the stack, right? Eventually in the stack, what we're going to do is we're going to have something kind of like this. That was not what I wanted to do. Here we go. So we're going to have like all these memory addresses in here. Okay, this is too slow. Here. We're going to have like all these memory addresses, right? And eventually what we're going to do is that return address, right? That we've got right here. That return address is what we're going to overwrite. So we write down the stack and eventually we've got a return address. That was a hurt. They were all. We've got a return address that we're going to overwrite. So we've now got our payload essentially here somewhere in the stack, right? So we got to figure out where it's actually going to live, where it's going to load, and then other stuff could be happening. Other instructions could be happening kind of like in between these. In fact, hang on. Let me do this. So down here would be like our return address, right? And then this would actually be like just additional instructions that are happening. So before the return address happens, which triggers the crash, we got to go see like what's the state of the stack in here and figure out what's going on with it. Somewhere in here is a memory address that what we want to do is we want to have return point to that memory address. And then that would be inside of our payload and we could execute it right in here. So this is a very, very standard like stack-based buffer overflow. Let's see what they've got in here. So in order to do this, we may need to know how many bytes to overwrite before we can reliably control what's written to the stack that is eventually popped into EIP. So for this, we can use Pwn Tools Cyclic. Ooh, a new tool. It's a Python scripting window, and we can use cyclic and how many bytes we want to do to generate a pattern that we can use to find the crash offset. So after generating the pattern, we can feed the pattern into the binary while it's being run with GDB. And then once it crashes, we can find a pattern in EIP. Copy that EIP pattern in and use cyclic find in the pattern. So this is basically, I guess, the newer version or a different version of what I was used to doing using Metasploit with pattern create.
So the first thing is you have a limited range.
Awesome. So we're going to go find our newest. So this is all inside of GDB, I think. Maybe? It's a Python function, but hold on. What did it say it is? So for this, we can use Pwn Tools Cyclic in the Python scripting window. Oh, okay, we're going to have a different window for this one. Okay, nice. I want to do this. Yes. Let's get some buffers overflowing. Hint. I love the buffer up there, though. I think that's the best tip jar in the entire thing. All right, so what are we supposed to do here? So how many numbers of bytes do we need to overwrite to control the instruction pointer? All right, so let's go over to our, here's our exploit editor. Here's our terminal. This is our offset finder. So enter input. Hold on, I thought we had like a Python terminal.
You would think that you would hear a different thing, but you don't. Now this one, and I'm going to show you what this is. It seems really simple. You hear things that happen in the world. Air vibrates. It vibrates your ear. Your brain hears it.
Oh, so this, I see what they're doing here. Hold on, let me restart this one. I wish I could clear this. That would be one feature I would really like to have in here is clearing this out. So let me see. So enter input A. Hold on, how much space is it actually expecting in here? Let's see. 64.
The pitch rising.
Binary exited. Press enter to restart.
I'm gonna show you what this is.
I did. Okay, restart. I don't know how many A's I put in here. Oh, damn it. It control C'd it instead of copying it. Hang on. Copy.
Probably what it was.
Restart.
One of the cool
Hold on.
things your brain can do is another thing
That's way more than 64.
tinnitus. If you have hearing damage, you'll actually
There we go. So now we got a different exit code. We got an exit code 139. Hold on. I'm going to take all that and copy it.
process that frequency.
Because I want to see if I get a different exit code again. Do I get the same exit code? Exit code none. It just crashed out immediately. All right.
Your brain really likes to react to things.
So, hold on. Because in the lesson, they said we would have cyclic in here.
Between 2 and 4 kilohertz, and your brain really looks for those signals. So, that sounds like it's continually going.
So this says this would be like generate a pattern. But that's not in... Yeah, that's not in GDB. Terminal, let's see.
You also have.
So how am I supposed to get the pattern in here?
If you hear but it has a hole in the middle, so it actually stops.
Rude.
You'll actually continue to hear. Your ear
Here's our source code. Terminal.
information, even though it's not there.
Am I missing something in here? I thought there would be, from reading the lesson, I thought it would be in here.
And you'll still feel.
So we can use cyclic to generate a pattern to use to find the crash offset. After generating the pattern, we can then put this into the binary. So is cyclic not embedded in here? Yeah, it says it, use it right here, but I was like, okay, do I need to go like download and install cyclic? Because we don't, I thought that was like maybe an extension over to GDP, but it doesn't look like it is. Enter input. Bubba. You said Bubba. Code 0. Boom. Okay.
This one's really weird. And you dub out the sound and put in a different sound, then the person will actually hear.
I said a thing. There we go.
Crazy how multimodal the brain is in respect to hearing. And all of these tricks make it possible to do audio compression.
I really like this, but let me see. Pwn Tools. Cyclic.
So one way to do
Cyclic online?
the absolute threshold of hearing or equal loudness curves. Basically, this is how well you can.
I don't have cyclic installed. I don't want to run cyclic.
And at the low end and the high end, you can't hear very well. Well, at a certain point, you can delete all of those things that you can't hear very well because you can't hear them anyway. There's also
Let me see something here.
and in masking,
Maybe I can run it like with UV real quick. Because if I can run it real fast with UV, then I won't need how to do that. Let's see. Installation. Let's see.
so you might as well delete that. And the weird thing about masking is it even works in time. So even if the sound is before the
Let me skip that one. So here's our binary utils for like Windows. Let's see. Windows support is experimental. Of course it is. That's annoying. Man, I don't have anything set up for it. Hang on one sec. Maybe I can come over here and set it up in our Kali box real quick. Let's see. We were done with all of this. Exit, 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 exit. We were done with all of that. New TMUX session. Hang on. Let's see. Install on like Ubuntu. We may be able to do that with this. Let's see. So if you want to build everything by hand, you don't want to use any of the above OSs, you can simply build by hand. Maybe it would already have it. Hang on. Let's see. Let's do sudo apt update. Maybe we'll already have it in the Kali repos, and we can just pull it down real quick. If not, I think the Ubuntu one may actually work for it. Let's see. Let's do app search pwn tools. CTF framework for exploit developments. Okay, let's go get that. All right, there we go. This is suboptimal. I would have thought that, hey, we're running a really simple... Oh, did it only load it? Damn it. You know what I think it did? I think it loaded the Python package. It did. Damn it. Actually, no, here we go. It actually looks like it came back correctly. Nice. All right, so do we have cyclic? We do. Okay, so pwn cyclic. Give me, oh, we'll say like 200. There we go. So what this does is it goes through and it makes a unique string that's going to help you find the offset for it. So let's copy that. And then what we'll do is we'll go drop this down into the binary here. So let's go back to our debug test, restart this, and then we'll drop it in, and it should break just like that. Nice. So now what we can do is we can actually come in here and run. I believe it said just pass in the argument. Let's see. Oh no, we need something in here. Paste the pattern in. Do I legit need those? Let me see. Yeah, I think we just drop it in. All right, here we go. So what we want to do is we want to look at EIP right here. So here's our offset, AAVA. And so to find the offset, it wants to actually, according to this, it wants like the full hex pattern. I want to try this though, real quick. So let's come back over to the debugger. Sometimes we can just drop in this part right here, like this. I want to see what it does. Let's see. All right, so now it should be like... Look up offset value. There we go. All right, so now we should be... Do lookup instead of printing it. Okay, so TAC O. 82. Boom. Cool. Hold on. I want to test one more thing, though, real quick. If I come in and I put in the hex value, will it give it to me as well? So now what we know is that at 82 bytes is where we actually want to go put whatever instruction we want this to jump to go do. Let's see. Okay, so it'll take either. If you've got something that renders nicely in ASCII, you can just drop it over in there, which it should be. It's all alphanumeric. But then also you could drop in the hex value there. So our offset for this is now 82. So how many, let's see. So what's how many of bytes, how many number of bytes do you need to overwrite the control instruction? We need 82 bytes. Ta-da! There we go. Excellent. Continue, continue, continue. There we go. So something else we want to go look at with this is we then also need to know like where on the stack we could find the information that we want. So if this was not using like static memory allocation, then we would want to have something that says, hey, maybe right at our, where is it? Up here, right? So ESP is pointing to the end of the stack frame, right? So we might want to tell it, hey, by the way, you're going to jump to the end of the stack frame down here and get that. Let's see. Did we just do seg fault analysis? Yeah, we just did that one. Hold on. It's just doing the thing where we got to go back into it and then back to game. And there we go. All right. So now we've got our stripe test. Let's knock it out. Let's do this. All right. So the goal here is submit the flag. Into your name. My name is Betty. Hello, Betty. Do we have a debugger in here? So here's our debug test. All right, so how are we going to get it with this? Let's see. I tell you what, let's just go drop this back in there. See what happens. Seg fault caught. Here's your flag. Okay. Seg fault caught. Here's your flag. Okay. So that one could use a little bit more instruction on it because it's like, okay, get the flag. How? Do you just want me to crash it? Okay, I'll crash the thing for you. That's fine. Crashing a program is not the hard part. Continue. There we go. All right, so we finished the first one, I think. Now it should be this one. Hey, Potion, what's up, man? Gonna be crashing the party. Oh, good. The T finally chilled out enough. The only thing I wish this mug would be a little bit bigger. Usually, when it comes to mugs, I am a size queen. But I just love that. Look, you can see it start changing back, right? There's Luigi and Toad. All right, so challenge 2 is, what's the offset to gain control of the instruction pointer? Just compress the T. But it's water-based. Water doesn't compress. Oh, let's see. So what are we doing here? Enter the name of your student. We do FGETs. We do final score. Let's see. We got a 128 here. How lazy do I want to be? That's the question. Pretty damn. I want to be pretty damn lazy. I'm just going to throw way more info than I know it's used to handling. Let's see. Enter your student name. There we go. So where did it crash at EIP? It crashed at ta-da! 76. Okay. I'm just being so lazy. I'm like, I don't even need to read the source code. I know it's vulnerable. So I'm just going to purposely throw way too much info at it. Now, they could have done something sneaky in there where, like, they checked the size of the input, and if it was outside of a certain range, then there was a different error handler to basically mess it up. I didn't think they'd do that, so I just cheesed it. Just have less water, duh. I can verify the water can compress, in fact. Water is not compressible. It does not like it. It is no bueno when it does that. All right, what am I doing here? Submit the flag. Okay. Run. Enter your name. My name is Betty. Here we go. All right, so now I have no idea what happened. I just crashed everything. Here's our disassembler. We have our exploit editor. It's called ice. Ice is not compressed water. Damn it, my brother knew that Fisher Stevens was Ben Javari. Of course he did. He's got an encyclopedic knowledge of useless facts. I mean, if you compress water enough, you get ice. That's not how that works. Hold on. I'm so brain cooked right now. I'm trying to remember. Hang on. No, that's not what I wanted. I just want to see the... I just want the diagram. Here we go. All right. So water is a solid depending on the temperature, right? So here's our solid liquid gas triple points right here, where it's like if you can keep the temperature and the pressure in these regions, then you get it like in all three phases, right? Just move up and eventually get solid. Okay, you're technically correct, but isn't like 1 terapascals? Okay, so realistically, you got to get above, what's this? 10 gigapascals, right? All right. What is the atmospheric pressure of Jupiter? Jupiter. I didn't define a limit. I'm going to define your limit, monkey. That's what I'm going to do. Okay. How far down into Jupiter do you need to reach a pressure of 10 gigapascals? You'd basically have to be like, I think, damn near the surface. Let's see. You'd have to be roughly 500 to 1,000 kilometers below the 1 bar surface level of Jupiter. And 1 bar is going to be pretty high up there. Okay. You guys were technically correct. The best kind of correct. But you're also assholes. I feel there's a your mom joke in there, but I'm afraid to explore it. All right, let's see here. All right, so all they want us to do is go find out wherever the flag is in here. So in main, all right. So the terminal, I think, just runs it. It gives us a name. It does stuff. Here's our debugger in here. Let's see. Let me check something real quick. Info functions. Oh, it's so much. There's so many functions loaded. So many that it went off the map. About list. Info variables. Yeah, science, bitch! I compressed your mom last night. Don't compress her. She's 84 years old. You'll break a hip. She'll break a hip. Let's see. Backtrace? Let's see. Oh god, I went through so much stuff. Corrupt stack? Yeah, probably a corrupt stack. Your mom's corrupted. Okay, hold on. What does exit do? Just kills it. Oh no, can I not restart the debugger? That was a mistake. Reset. All right, so what did the decompiler actually come through here? So hold on, I forgot. This will actually list our functions for us. So we've got debug main, debug vulnerable here. All right, so then we're going to take out a sub ESP of 48. We enter our name. We do a syscall to printf. Let's see. Oh, sorry. We'll do a call to printf, and then we're going to call standard in. Hold on, I got to figure out like where this offset is, like what it's doing real fast here. Let's see. Using pressure is how you get some of the more exotic forms of ice. Yeah, weird stuff starts happening to materials when you start getting like super high pressure on them. You start getting really high pressure or really high temperatures. That's where the really odd stuff happens. Let's see. Hold on, so after it does this, it allocates another 4 bytes onto the stack, pushes EAX, pushes 128 onto here. And then it says, hello. Hello, children. Here we go. See this? So we do have an F open in here. So I think we could do the same thing we just did earlier. Break on file open. No. We don't want to break on file open. Because file open is where everything's going to kind of like get... Because it's going to do the file open, then it's going to read it, and then there hopefully is something after that. So let's see, do we have another one in here? We have puts, and then we have flush. There we go. Break on F flush right here. I think that might get it for us. So break on F flush. There we go. Run. My name is Betty. My name is Nerd. It did not like that. Oh, you know why? Because that is the seg handler, right? So if we run this, we do need something really long to go crush this buffer. Giggity. So hang on. Here's what we're going to do. Copy that. Let's go see what happens. All right, so here we go. So now, let's see. Zero capacity parity adjusted. ESP's here. Let's go try backing it up a bit. Let's use a smaller buffer here. I think it was allocating like 128 on there, so let's do like 150. We'll do a teensy buffer overflow right here. Let's do that. Copy that, and then let's come back over to here. Well, let's see. Should be a Discord team if you want to meet up on Wednesday night. Okay, man. Yeah, by the way, anybody who's in, like, around North Carolina, I'm going to be in Charlotte. I think I'm going to have time to get together Wednesday night. I don't know exactly what the entire schedule is, but yeah, hit him with an arm bar. I'm a bit more partial to, like, the sleeper hold. You know, just... Shh. It's okay. It's okay. It's okay. It's okay. Just give him a good little choke out there. I could do arm bars. I was never really fantastical at them, but I could get them. I just resort to the old pecker twist. I'm gonna break the wrist and walk away. Break the wrist and walk away. Let me see. Let me try running this again. All right, so now where's EIP pointed to? EIP's pointed to Ta. Wait, hold on. We saw where Ta was. That's 76. All right, so let's back this up a little bit. Let's do 80 in here. So we're gonna get a smaller buffer to put in here. Okay, so run it again. All right, so now where's EIP pointed to? EIP is still pointing to Ta. It looked like from the decompiler that we had a special, like, segfault handler in here. Maybe I need to just jump to that. I'm going to try it. You know what? We've got the address for it right here. What is this? This is 492006. Here we go. Here's what I'm going to do. I'm going to overwrite that, and I'm going to put that in there. And I think that just kind of happens to work. Let's see. Maybe that'll work. Let's see. No, that won't quite work because those are not ASCII printable characters. Damn it. Yeah. Bow to your sensei. I love the part when he walks in on Uncle Rico with his wife and, like, he's got the pots, right? And he just looks at him just... I kind of feel bad for the Napoleon kid, the kid who played him, because he was in a couple of other good movies, and then you didn't really see him after that very much anymore. So, like, I wonder what he's been up to. I want to see if I can get it to jump to here, but I'm trying to think how to get it to go there. I'm not sure how to do that. I mean, I don't think this is actually where they're going with this. And here's what I'm thinking, though. So over in the decompiler, right, we see this segserve handler here. And this sigsev handler actually goes and pulls challenge flag, right? Let me see something real quick. So can I break on sigsev? Hey, Go Overlay, thanks for coming online, man. Welcome in. I hope you're having a absolutely amazing, wonderful Sunday. Wonderful Sunday. Happy Sunday, everyone. I had a pretty good one. I'm a little brain fried right now. Like I said, I don't know if you can see it. I might be burned, like on the top of my head. It's feeling a wee bit tender because Honey Badger, my 4-year-old son, right, he was out at the track with me today. And so I gave him my hat, and then the little turd bucket promptly filled it with dirt. So I didn't have a hat, and he didn't have a hat. Yeah, he's like, but I didn't fill it with dirt. I filled it with sand. I was like, it's the same thing. Nice. Good tea. Hey, Bobby, what's up, dude? Dude, I saw all the news articles you posted up in the Discord. I was like, damn. He's really scraping the news for me. Which would be good because I'm going to be since I'm traveling, I don't know how often I'm going to be able to keep an eye on it to kind of put stuff up for Thursday night. Oh, thank you. Actually, Bobby, you just reminded me. By the way, guys, Wednesday night news will be Thursday night news because I'm going to be traveling. So I won't be back in town until Thursday. So we'll do the news Thursday night. We'll get on with that. Of all the things you could have binged on, you decided to go binge on the news? God, what a freaking loser, man. Gosh. Freaking idiot. Plenty more to come. Actually, hang on. Did y'all hear about supposedly was dropped that... Hang on. Let me see if I can find this real quick. Let's see. Yeah, here we go. Check this out. So this whole thing really originated from one reporter at The Economist, but they paywall everything. Hey, Killer, what's up, man? Oh, no, so the new stuff is over in Discord. It's in a Discord thread. So we set up a thread every week. I drop articles in there. Potion and Bobby drop a lot. Guy posts a lot in there. But anybody can go just drop something in there if you want to. And then we'll go through it and we'll pick out like what we can cover during the news stream. But yeah, check this out. So this is from The Economist. Everybody, but nobody can really directly cite it because Economist has all their articles behind a paywall. But it says, NSA and Cyber Command Chief General Joshua Rudd said Mythos, quote, broke into almost all of our classified systems, not in weeks, but in hours. Now, that's the direct quote, but there's more to it around that. Hang on, let me see if I can find... Because I actually stored this earlier so I could find it. There is... Crap. I don't think it's saved. It didn't. I mean, I know I've got it on the server somewhere. Damn it. It's not showing up in here. But there was somebody in here who replied to this. They actually had a blog post talking about it. The quote makes it sound like it was Mythos operating like completely 100% independently. There's a lot of context around it. But also, this happened, I think, during a closed door session. So even if there is going to be a transcript, those are delayed by like weeks or months. I'm trying to figure out something else happening here. This was a week after Washington forced Anthropic to disable its most powerful model, and likely the reason is sharpening. So according to the reports, Senator Mark Warner told a hearing that the NSA and Cyber Command chiefs said the firm's Mythos model penetrated almost all the agency's classified systems within hours during authorized testing. So, you know me, guys. I do this stuff pretty much every day for the last 8 years. There's a whole lot of context goes into that. Any fool can go break into a computer. It's a very, very different thing that AI very, very sucks at to do it quietly. So just because it found a way to go do it doesn't mean it's not a secure system. It just means that, because there's no system that is 100% perfectly secure. It means that it just did it. This is 50-50, either IPO hype or Anthropic trying to get regulation locked down while they're still getting the regulation locked down while they're still the top dog. This actually supposedly was very much said. However, damn, I wish I could find it. There was more context to it than that. Hang on. Let me see. I forgot who the author was for it. I love Adam. He's so funny. It's time for the smug face. Because he got an air conditioner for his office. Anyway, the future's open models. A company like Anthropic cannot control intelligence for a price. I know, right? Dude, I really want there to be open models. The problem is that the state-of-the-art models are just freaking huge, man. We cannot even make big enough hardware to run them. Like, you're talking, it's massive amounts. Like, let's say, like, it's estimated that, like, some of the state-of-the-art models are, like, 1 trillion parameters, right? So that's a petabyte of memory to 2 petabytes of memory. VRAM, fast memory, DDR5 that you've got to have to run that. Yeah, no, there's a lot of people were taking that out of context. And I wish I could find the other article. I will go find it and remind me, Bobby, since you're the one who will likely remind me. Remind me and I'll go throw that rebuttal blog post. I'll go throw it up into Discord. Just remind me. I'll try to remember to pull it out. Excuse me while I whip this thing out. I've got a plan, but I don't know how to make it work. Exploit editor. Oh, hello. Enter your name. My name is Cyber Digest. Stop. Hold on. Now, okay. I didn't realize this is what the exploit editor could do. Okay. This is like their... We could actually... Okay. No, this is perfect. Hang on. Hang on. I've got the memory offset over here. Oh, hold on. We actually had it over in the decompiler here. I want this to jump to it. So here's what I want to do. I want to do... Let me see. Can I do p.send line? And what I want to do is I want to send a bunch of A's times... what was our offset? Our offset was like 72. Yeah, 76. So our offset is 76. So I'm going to send 76 of these. And then I'm going to append to it a pen to it. Are you gonna let me? Hold on. Didn't I copy you? Copy. Paste. There we go. I think I could do it like that. Except, hold on. There's gonna be something a little bit different. I don't know. Screw it. We'll just run it. Enter your name. We do it? Do I need to not do interactive in here? And then I think I need to do, then send a, like a \n. Cannot concat into bytes. What? I gotta remember how to do this in Python. I'm probably overthinking this a lot. But what I want to do is like make it control jump over to it. What's the lesson say? Complete all challenges. Test. Okay. All it wants us to do is get the flag. Let's see. Is this a different topic from Active Directory from last week? Yeah, man. So we're looking at, if you look at the pinned comment over on Twitch, there's a bunch of buffer overflow challenges, and I just wanted to mess with them this weekend. I wanted to take a look at it. It came up during the news stream on Wednesday. It's called Binary Jiu-Jitsu. And if you're interested in buffer exploits, it's a very good place to get started with it. So far, I'm liking it. The very foundational stuff, the white belt stuff is very good. Thankfully, I remember a lot more than I thought I did. But it's been pretty fun. So that's what we're doing. We're just tinkering around with it tonight. We'll probably go back to doing some other systems next weekend. I just thought I'd give it a go this weekend for Saturday and Sunday. So what we're doing right now is we're doing a test here where we're given some code, but we've only got it in the debugger, we've got it in the decompiler, and then we got a couple other things happening here. Hang on one sec, guys. My mom's calling me. Be right back. All right, everybody who claimed that my mother was reminding me to poop is banned. Yeah, I can just imagine my mom actually doing that though.
Hi, sweetie. Have you had a good BM today?
I've well into my 30s, and I had to go to Las Vegas for a convention. It wasn't DEF CON, it was for something else. And yeah, my mom calls me like, I'm just checking on you. It was like, you know, I'm a full-grown man with a wife and kids, right? And she's like, I know. I was like, you don't act like you know. And she's like, well, what are you doing? I was like, I just got off my flight. I'm tired as hell. It's hot outside. I'm sitting in my hotel room watching a Star Wars marathon. That's what I'm doing. Moms do be like that. Dude, I would love to get a Sparks, but they're like $4,000 a pop. Yeah. Well, she was giving me an update on a little trip that she took with one of my cousins. And so I was like, okay, Mama, I would love to hear about this tomorrow, but I can't talk about it right now. Yeah, you get back to your hotel and you have 3 minutes before your mandatory team dinner. Yeah, exactly. All right, I'm not sure what they want from us. I can see where this is pulling it from. Okay, so actually here we see enter your name. So actually we could kind of do this right here. And then what I need to do is, I don't know what send line actually does in here. Let's see. I gotta remember how to do something real fast. I think it's \x and then the hex value. But then also the way it writes it and the way it reads it, you actually typically have to put it backwards. Okay. I'm gonna do something real quick. Let's do let's see. This EIP target, and that's gonna be this value right here. And then what I'm gonna do is let's see. Hang on 1 second. The Sparks aren't that expensive for what they provide. I mean, if you've got a valid use case for it, then yeah. It's really hard though, because even with Anthropic, where they're priced right, to use Anthropic and be locked into their ecosystem at that price point, I literally have to get more than 4 years of use to get the monetary reimbursement for it. Walmart is selling a DGX Spark. That sounds terrible. Yeah, I know, right? God, I'm trying to remember how to do this. Let's see. Hang on, I'm trying to check something real quick. Sendline may not even be able to do this. I'm not sure. I have to go check the Pwn tools thing in here. Let's see. All right, here we go. This is what I'm looking for. So typically you have to, if this works, we'll see. This won't be value. This will be EIP target. And then what we'll do is we'll join those by S. And then here's what I'm going to do. I'm going to do this. I'm going to do plus S. I'm going to try this. We'll see what happens. And then I'm going to comment this out here. Run exploit. Did I crash it? That's going to make me sad. You try restarting the containers real quick. Glad I saved that. Let's see. Can't concatenate a string to bytes. Okay. Actually, I think this is what I needed here. Instead of join. There we go. So those are bytes reversed. Hold on. Yeah, this is incorrect. Hang on. Errors replaced. No, that's not what I want. I want to... Ah, damn it. That's not going to work. I'm probably taking this down the wrong path in here. Because what I'm thinking is go, like, overflow it and get it to run to there. That's probably not what they're expecting, though. So, let's go look at vulnerable in here. Hold on. So, we're in main. Does main call vulnerable? Let's go see. That's why you need to have local, because students going to crash. Dude, if I had the money, man. Unfortunately, I don't have a spare 10K laying around to get 2 sparks and the connecting cable between the two of them. I almost got a spark. I tried really hard to convince my company that I should be able to get a spark with my professional development budget. But they were like, no, unfortunately, you can't do anything with hardware. So what I need is, I need a course that costs $4,600 and comes with a free spark as part of the course. That's what I need. All right, so let me look through main here. Actually, we have to read through the decompilation here. All right. So here it's going to call set vbuff, and then here it's going to call the sigsev handler. And so this, let's see, so we're looking at main right now. If we look at the sigsev handler here, let's see, here's fgets, fclose, file print. Well, so we're pushing onto the stack, we're pushing This would be file not found. This is jump if not equal. Hold on. Here's the challenge flag. And then we're going to call F open right here. So then after F open, then we've got a jump not equal. We're going to allocate some space onto the stack. We're going to push file not found here. And then here we're actually removing stuff off the stack. We're shrinking the stack. And then we're going to move the stream over to EAX right here. Monkey, what do you mean it's the golden pricing era? Yeah, there's a whole lot of people like really pissed off about how many data centers are being built to use that are sucking up all the components. That's why I can't get a 10 terabyte hard drive. Hold on, let me go look at vulnerable again. Let's see. Hold on. So hold on. Let me go back to main. Does main even call vulnerable in here? So here it calls vulnerable at the very end, right? So if we go to vulnerable, you enter your name. And then after vulnerable is done, then we go back to main again. Let's see. Demonstrate control over EIP by... Oh! I'm sitting here like, what the hell do they want from me? I guess it would help if I read. Yeah. Sometimes you just got to RTFM. Demonstrate control over EIP by filling the buffer with A's and overriding the return address with B's. I'm an idiot. I'm an idiot! I'm an idiot. 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 Actually, this shouldn't be that. Should be like 72. Oh, that's actually pretty cool. Crash detected, but EIP is here. It was 72 as the offset, right? Let me see. Debugger, run. Drop this in. All right, hang on. Now that I know what I'm actually trying to target, and like not just epically failing. Hang on. Run, drop that in, boom. Where's EIP? Offset T A. So offset of T is 76. That's what it was. That's where I had it. It's not 72. It's 76. There we go. That's the debug mode. Go to remote, get live, run it. There's our flag. God, I'm brain cooked tonight. I was like, okay, cool. Do we need to like buffer overflow this and jump to this the 6sev handler? No, we just had to actually read the instructions. Hold on, let me go look at this link real fast. So I think Walmart is trying to kind of like muscle in on Amazon stuff where they're not necessarily selling it directly. It tells you like who the seller is. Hey, why get one for 4,700 when you can get two for 9,500? I'm not trusting my mathing right now. But this is 4,700. This is $50 more to get two of them. Hey, Palmer, what's up, dude? No, I am not trusting my math right now. I was out at the track all day, Palmer, and I am cooked. Oh, the 2-pack comes with a cable. Oh. Damn, that's an expensive cable. I know, it carries a lot. I got it. Add to cart. Save that for later. No, I won't. Sock would absolutely murder me in my sleep. Hack the Planner, what's up, man? Yeah, apparently it did come with the cable, dude. Yeah, I saw one of the guys on YouTube do a video where he was like bringing them together through this whatever that 10 gig switch was, I think it was. And it was the networking equipment was enormously expensive for those things. I was like, damn. I'm gonna get me a 3-pack. That's right. Get me a 3-pack. Oh, you're gonna make me go through this again, aren't you? Hang on. Back to game. There we go. It finished it. Awesome. Unfortunately, I was hoping to get through Strike 4. I wanted to finish White Belt tonight, if I could, before we got through with it. But at the rate I'm going, I'm not going to get through it. I'll probably keep going through this for fun, so I can do like a full review of it. Because I really like to do like a review video on it. That cable alone probably costs hundreds. I don't know, how much it? Let's see. What cable is needed to network 2 DGX Sparks to get her? Oh, it's using 100 gig Ethernet cable. How much they cost? I'm just asking Grok real quick. I'm curious. Let's see. Depending on the length, they can cost anywhere from $50 to $300, which you don't need a very long one in there. Prices vary by brand and length. 1 to 10 meters are common. You know, if you've got them right next to each other, boom, you're good. Anything over 2 devices, you gotta have a switch, and that gets expensive. Yeah. Yes. Yeah, because you also have to have the QSF piece for that too. So hold on. I gotta go look at that now, because now you'll have me morbidly curious. Wait, where's the 2-pack? Oh, hold on. I have the 2-pack in my non-existent cart here. Hang on. View item details. Let's see. I want more details. Let's see. But what does it come with? Color gold. Hold on, where does it say it comes with the cable? I'm not doubting it is, but I wanted to see, like, did it come with the cable and everything else? Comes with a USB-C? No. No. Are they selling the 2-pack on the NVIDIA site, guy? Is that what... Are they also doing that? Let's see. Any computers with a 5090 in them? Let's see. Cyber Power PC. That's like the wish.com of PCs. Unfortunately. My brother got one time and it was abysmally bad. So that's for the official NVIDIA one. But hold on, they've got other Sparks on here. Basically the same thing, just different skin on them. Like the Asus one saves you a bunch of money. Do they have a 2-pack of this one? Oh, here we go. Sold and shipped by Newegg. This one here, sold and shipped by Newegg. So you're essentially buying this from Newegg over Walmart. Let's see, DGX Spark. See, this one, their 2-pack is a different price. So I don't know if maybe you're getting a discount by going through them. Okay, here we go. Here's the like I think the exact same one. Yeah, so this one is a cable with the QSFPs already on it. So you'd be good on it. I just thought that'd be weird, like if they sold it without, like if it was just the cable by itself without the SFPs. That would just be really weird. Oh, it's a 200 gigabit connector? Damn. Damn! Can move a lot of data with that. And here I thought, what am I ever going to do with 1 gigabit per second? Well, apparently not enough. I don't know if I'd call that a very good deal, but it's a decent deal. I wonder if they have any other 2-packs. Because they've got the other ones in here, like the Asus one here. Why is this one so much more expensive? You guys have just sent me down the rabbit hole for tonight. Let's see. Oh, probably storage, if I had to guess. Yeah, bigger storage. I bought it. Need a dress for you, Daddy, and I'll send it to you. Gumby, if you sent this to me, I would probably firmly, squarely kick you in the nuts for doing something that dumb. Nobody should be spending that much money on any live streamer. Any. There was a short clip of some guy that gifted like 1,000 subs to Emeru. And even she was like, what the hell are you doing? The real question is, after you kick him in the nuts, are you returning it? No. Gift freely given. I had to dig into that style of networking when I was working at a HPC data center. Oh, okay. See, I did a tiny bit of that, but that was like 16 years ago. No. Take it back. This was about 12 years ago when I was working at my first job out of university. So, and it was a Splunk cluster is what it was. It was for connecting the storage array to the processing array. That's what that was. Dinner date with Blaise for a pair of Sparks. You know what? Yeah. Buy me. Yeah. At least I'll buy you dinner. There you go. God, that's not even fair though, Hats. I'm such a cheap date, man. I don't really drink. It's like, and that was actually, I used to joke with Sock about that too. She doesn't really drink at all. If she ever got a drink, I knew she was going to drink about 10% of it and I was going to get about 90%. So I never ordered a drink because then she'd want to go try something and she'd be like, oh yeah, that's really good. Here, have the rest. And I would end up drinking it. Oh. If I can get something worked out with a certain housing situation that I'm trying to do, guy, then maybe. But that's a very big maybe and a very long horizon. All right, let's go here. Let's finish up with this this part we're doing right here. All right, so we're talking about control flow hijacking. Of course, as soon as I want to get started, I feel like I got to sneeze. It's brutal. All right, so once we know how to target EIP correctly, so we already identified the offset to control it. Next, we need to craft a payload that in such a manner is reliably overwrites EIP with a specific value that we choose. So in the exploit editor, we can print a payload and then send it to the application through GDB and see the registered data. So if our offset's correct, then EIP should crash at 4242, and then we can reliably control it. And that's exactly what we just did. Okay, so what does 42 and 42 in the EIP prove after sending 82 A's and 4 B's? What does this confirm? The binary has ASLR enabled? No. You have successfully overwritten the return address on the stack and now control EIP. Yes. All right, what's our other question? Let's see. Bad offset. All right, so after sending 82 A's and 4 B's, EIP shows 41, 41, 41 instead of 42, 42, 42. The offset is too large. The A's are overriding EIP instead of B. There we go. Bam. All right, cool. That worked. Ret to win. Ret to win. That's funny because I was actually just listening. I was in the car. We're driving back from the track. Honey Badger's in the backseat in his car seat, crashed out. And Live to Win by Paul Stanley, I think is, came on. And instantly my mind went back to the South Park episode, Make Love, Not Warcraft. Or Make Love, Not Warcraft. I think that was the episode name. Ooh. Let's see. Wife and I also don't drink, so when we go to Sweden, we don't even notice that they don't sell booze in the grocery stores. Dude, when I moved to Louisiana, Pat, so I live in Texas, right? And in Texas, a lot of liquor and alcohol distribution is regulated kind of heavily. Usually you have to go to like a dedicated store and they don't allow it being sold inside the city limits. It's kind of archaic. But anyway, when I went to Louisiana, though, they just had that stuff in the Walmart. That's what blew my mind. Yeah, those old blue laws. Let's see. All right, let's look at this one, Ret to Win. So a Ret to Win challenge is a cheesy CTF challenge that gives you an easily exploitable binary that contains a win function. Nevertheless, it's the hello world of the exploitation world. So the idea here is if you can control EIP and reliably override it, we can write the address of the win function to the stack and have EIP jump there when it returns from the vulnerable function. So here's our win function right here. We have a greet. So when we do this, we assign a variable. What's the student's name? We do an fget right here, and then we greet them. So the idea here is that rather than doing a jump to greet, we're then going to do a jump over to win right here. You should see how dumb the people are in Quebec. They want to be taxed. Oh, dude, I am pissed about taxes. So previously, the nicotine pouches in Texas were not taxed as tobacco products. However, the law was understandably, predictably, vague enough that now they can tax these things. And so when I used to place an order for this, the tax on that order was on the range of $12. It was basically sales tax. The tax, if I was to go place that same order, is now about $110. So, Texas Comptroller, get fucked. Oklahoma was really bad on the blue laws. Also, you couldn't buy liquor on Sundays and couldn't buy beer over 3.5% in grocery stores. I think a lot of the liquor stores in Texas still had to be closed on Sundays. Okay, Overlay, have a great night, man. Thanks for stopping in. I understand the time zone, dude. I understand it, man. But I hope you have a great night. Take care. Have a wonderful Monday. Get into crushing it mode. As Jeff Bezos said, the bottom 50% should not pay taxes. Dude, it's also crazy. Taxes are nuts. We turned a whole we turned a whole harbor into a giant teacup over a 3% tax. And now people are just cool that like a fucking third of my income goes into taxes. And you know, I just realized like I'm way behind on the swear jar. Let's go fill that up. There we go. In fact, I need to do it again. All right, let's see. So anyway, all we're doing here is we're proving that we've been control over EIP. In this example program, the string copy buffer is 128, and it copies to a 64-byte buffer. So this is our overflow. Without even opening the debugger, we can calculate the offset to be 72, because we need to fill 64-byte buffer. Overwrite 4 bytes for the base pointer, and then there will be 4 additional bytes for the stack alignment. So keep in mind, compiler optimization and other known factors can cause this math to not work, but we have to confirm it with a debugger. Yeah, a debugger. So to find the offset, we do it like we just did. We do cyclic execute and then cyclic find. And then we prove control over EIP by writing a predictable value to it. And then we go check it out in there. And then to find the address of the win function, we can actually just do print and win to get the address of it. Okay, cool. So writing an exploit in Pwn tools, we can do interactive with it. And then we already kind of messed with this. We jumped ahead of this plot here. But we can receive until we get a certain amount, and then we can send line. Let's see. The P32 function is for packing the address into little Indian format. Oh, nice. I used to have to do that by hand, practically. So here we find the win address. We tell it what the offset is. We tell it our payload is A's multiplied by offset. And then we're going to do a little Indian packing of win right here. What's the student name? We receive until we get that. And then we do payload and then go interactive. Let's go do this. Debugger sounds like overcomplicating male pleasuring device. What's funny is the Texan complaining about taxes and what's a bigger reason given for moving to Texas. I know, right? Now, granted, also, the taxes in Texas they're different. They are less, but they're different.
The Teeb Monkey cheered 100 bits and says, "Bits for the fucking swear jar."
Thanks, Monkey. Appreciate it, dude. But yeah, so like, for example, there's not a lot of property tax in California, right? But there is a lot of property tax in Texas. And I hate the property taxes because they go to fund everything that I don't use. And then also there's a lot of other taxes that get made up here that a lot of people don't think about. The main thing that is awesome about Texas is there is no income tax. That's one of the biggies right there. Oh yeah, and the insurance is absolutely a racket. Dude, a full 35%, I think, of my mortgage payment goes to insurance and taxes. So my 30-year mortgage could be cut down to 20 years if I did not have to pay for those two things. It's such a racket. All right, let's go see here. So in our win condition, we got 128, but we're going to copy this to name. We're going to copy size 128, and then we're going to do string copy. Let's see. Hold on, where's name in here? So here's greet, and then we're going to string copy buffer, which is 64 bytes, over to name. Or sorry, we're going to string copy from name to buffer. So what we need to do is go grab our. Let's go grab our offset string. This one's like 80. This should be more than sufficient. Right here. Copy. And then let's go run this in the debugger real quick. Let's run. Student name. We get a crash. EIP is at ta. And ta, we already saw, was at 76. So then if we go to our exploit editor right here, then also we need to do something. Let's see. Win address. Let's go get that. So print our win function here. It's going to be this. So copy. So if we come back to our exploit editor, that's our win address right there. And then our payload is now going to be a bunch of A's. And we're going to multiply that by 76. And then plus what we're going to do is we're going to use that P32 function to pack in our win address right there. And then we're going to, let's see, where was it? Debugger. What was it? What did it print out? What is your student name? Right here. So let's copy that. So we'll come over here. What we're going to do is now we're going to do p dot resiv until this guy.
Virus infection alert.
A virus? What? It's the Hack Smarter virus too. Ah, crap. It's all those people that are like, oh, just be smarter. I'm trying. Hey, Tyler, what's up, guys? Welcome in, Raiders. Hack harder, not smarter. That's right. Noel knows what's up. Have you tried harder? Hey, Tufaco, thanks for coming online, man. Welcome in. Hack harder, smarter, not. There you go. Dude, Tyler, I saw your DEF CON badges, by the way. If you're going to DEF CON, make sure and call the meetup like, I forgot what like Conference Smarter. I think that's what I sent you. Whatever I sent you like months ago. But welcome in, Raiders. Dude, by the way, guys who just came in on the raid, first off, Tyler's awesome. You guys are all smart for being in Tyler's stream. But welcome in. My name's Blaise. I'm a red teamer, pen tester guy, breaker of things. Go check out the pinned tweet. I'm brain cooked. I was at the motocross track all day today. Go check out the pinned message over on Twitch. And what we're doing is we're going through a series of binary exploits called Binary Jiu-Jitsu. It's a really fun lab. We'll probably drop it off after this week, and we'll do some more like Windows Active Directory stuff next weekend probably. But it's been a lot of fun. I like it a lot. Yeah, this is actually. Can I show it without breaking what I'm doing? Hang on, I'll show you. So we're doing like the very first, like, hey, we're going to overwrite EIP. And then we're going to jump to a function. We're going to get the win condition. This is ret to win, the very basic hello world of smashing the stack. So this actually starts out really cool. There's different belts in here. We've just about in 2 days gotten through white belt. And that's with the chat constantly derailing me and like just really poking my ADHD. So we're doing pretty good. Especially if you got a foundation in this, they do a great job on teaching this. I have a few nitpicky optimizations they could do on it, but I actually really like it. Binary Jiu-Jitsu has been a lot of fun. Are you doing ropping? That's one of the coolest things I've ever done. I never really got to like rop chaining nullsec. I think I kind of topped out when it came to binary exploitation at secure exception handlers. That's about where I really went. Yes, and for everybody who just came in on the raid, should you feel so inclined, we found out that Walmart actually sells... Can I find it? Yeah, we talked about so many weird topics. Nope, that's not it. Closed. Yeah, Walmart actually sells DGX Sparks. In actuality, it's Newegg selling through Walmart. But it is still funny, you can go onto the Walmart app and order a DGX Spark on there. All right, guy. Have a good night, dude. Thanks for stopping in, brother. Mad Hacker. Name checks out. Yeah. Name checks out. So, yeah, we went on a tangent on like looking at the DGX Sparks and everything. We've kind of been all over the map. And with as brain fried as I am, that's what we've been doing. So what we're doing here is we went through our debugger, we got our EIP offset in here, and we're just building a quick exploit. We got the address for the win function. And so what we're going to do is we're going to build our payload here, and then we're going to send it. So let's see. So we'll do a p send line of payload, and I think that's it after that. Let's see. Can only concatenate. Oh, hold on. I know I did this wrong. Let me look at the example exploit code they did. Let's see. P32B. Oh, I think I did that right. Times offset. Let's see. Oh, no, this needs to be bytes right there. There we go. That's what I did wrong. Hey, win reached. Let's go. Okay, win reached. And then ls catflag.txt. Hey, there we go. Oh, damn it. I'm doing it in the debug. I wasn't doing it in the live session. Hang on here. There we go. All right, catflag.text. There we go. And we got the little flag. Hooray! And the peasants rejoiced. Yeah, I was honestly wondering that too, nullsec. I was like, is that Maddie, like, incognito? Speaking of YouTube, so I'm making a big push now. I finally got a lot of the technical issues sorted out with, like, basically just time constraints about making YouTube videos. So I'm getting back to making weekly YouTube videos on, like, interesting hacker stories. There's actually one up right now if y'all want to go check it out. This guy named Bob the Hacker. And he's got, like, Bob the Builder themed stuff on his blog. But anyway, he went and found an exploit in the FIFA website that would have allowed him to take over the World Cup live stream. Like, the stream that was going out to the media partners and everything. Dude literally could have, like, rickrolled the planet. So, it was a really cool read, and it was a stupidly simple bug. So go check it out if you like those kind of weird things. Let's see. All right, we did this one correctly now. We did ret to win. So there is, I'll tell you this, for everybody who just came in on Tyler's raid, there's a little bit of a weird bug. Like, we just did the ret to win thing here, and notice how it didn't advance us. After you win, sometimes you have to go back in, reload the challenge, and then you can back, once it loads up, then you can back out, and then it will unlock the next one. What was the hacker that took over the TV back in the day? Oh, like actually, there's been a couple of incidents like that, but there was one that was, like the Max Headroom one is the most well-known one. And there were other ones that like one was a satellite technician, and he ended up getting caught because his was like a protest style hijack. And so Max Headroom was like the most well-known one, but there's actually other ones in there. Oh, hang on one sec, guys. Let me check something real quick. Oh, okay. That was somebody reminding me. That was Gumby reminding me, hey, by the way, you have to go do this. Yeah. Oh, yeah. Happy Father's Day, guys. Robo, thanks, man. Yeah, I did have a really good Father's Day. Hang on. I'll show you something, though, that happened while we were out there. Let's see. Photos. Let me go find this real quick. Here. This was Agent Zero's quad right there. See that? That part's not supposed to do that. So this actually wasn't his quad. This was like a backup bike that we had that he was riding. So yeah, we spent the whole day out at the motocross track. Thankfully, I mean, this happened like during, like we had just started practicing. What happened, we guess, was after a couple laps, some of the bolts had vibrated out and one of them sheared off. The one that's in this connector up here sheared off. thankfully, one of the other guys at the track had, it's like the properly sized bolts. We were able to get it back into place and working. But yeah, I felt so bad for him because like we hadn't been there very long. He had only done like one series of laps around the track. But yeah, he felt really bad. He thought he broke it. I was like, buddy, you're pretty strong for a kid, but you're not that strong. No, if that failed, it's because something bad happened. Let's see. Mastering the stack. Targeting other data. Cool. Unfortunately, I don't know if I even have the brain power to get through this one. Let's try this one real quick. So, let's see. So sometimes our buffer overflow may be constrained by some other way that we can't reach the return address, or perhaps it's an easier path of gaining control flow deviation. So in those instances, be aware that other variables and data on the stack can be a great benefit. So for this example below, right? Oh, yes, dude, overwrite that. Is admin. Boom. If is admin. When. Right there. So in this example, if the function if the variable is admin is 0, then we miss the win condition. That's it by default. But you have to remember, this is going to be allocated on the stack because it's allocated in the function, right? So when the function happens and the stack gets prepared, we're going to allocate space for this. Let's see. So if we go and inspect the stack, sometimes while developing our exploits, we got to know exactly how the stack is laid out and how our payload is going to influence that. And so we're going to basically look at this in GDB. So this is looking at a 20-word hex offset at ESP. And then we should see like the address for our write primitives and then some other stuff in here. So this will dump the context of our stack right before and right after your write primitive. Okay. We need freedom size screws, driven by democracy rather than wrenches. That's right. No, actually, what's funny is he actually needed 8mm screws. A lot of these, so like the particular engine they're using are Malassi engines. They're Italian moped engines, basically, but they're really good. And so a lot of the stuff on there is, most of the stuff on there is metric. So yeah, it was a really good day. I took Honey Badger, also my 4-year-old out there. He's excited. He wants to start riding too. So I told him, okay, bud, next time we go riding, when we can, the weather in Texas has been really bad. It's been either just hotter than Satan's butthole, or it's been raining. So I told him next time we get to go, we'll bring his quad so he can ride also. He is very excited. Let's see. So we could look at overriding like individual variables like this, because we know that that's going to be a 4-byte integer, right? So we're going to find 4 bytes that are just zeros. And then also we might have to look at different structures that could be in there. Like for example, a structure here would be, let's say hacker, with a handle that's 32 bytes and is leet as an integer. It's okay, more rain coming. Oh, Gumby, I know, man. We're supposed to be having like the El Nino to end all El Ninos or something ridiculous. The Godzilla El Nino, threat level God El Nino. It's kind of nuts. Let's see. We can also try and go override function pointers. So in this example here, we have our function pointer to greet, but instead we might want to call admin panel. So instead of greet right here, let's see. Oh, so actually this is our struct, right? So our struct is a session. Session greet equals greet user. So that's going to give us the address to that function. But instead, we might want to override this. And instead of doing session dot or get username and then do session greet, but we overwrite that pointer in session to then jump to greet, admin panel instead. Okay, cool. Let's see if we can knock this one out real quick. Struct overwrite. And then this will be the last thing we do for tonight, and then I unfortunately have to call it there. I still got a pack for my flight tomorrow. So, oh, by the way, everybody who came in on Tyler's raid for the Hacksmarter crew, usually Wednesday nights we'd be doing hacker news. So But unfortunately, this week I'm traveling for work. So Hacker News will be on Thursday night this week. All right, let's go take a look here. So main will do, it's going to call the vulnerable function. So vulnerable has a struct for an employee named imp, and then employee.access level equals 0. And then we're going to do if employee access level equals leet, then go to win. So what we want to do is we want to overwrite this in here. So this is going to be a struct employee. So that struct, hold on, I got to go back to the lesson real quick. Let's see. So for this example, it's very similar to the previous one, except for the structure. So notice the structure is global. It isn't scoped to main. So the struct members aren't even on the stack. They're in the BSS. But the buffer overflow still works the same way. Instead of looking on the stack, you'll need to find the address for the struct in the BSS segment. Ugh. How do I find it in the BSS segment? Damn it. Because there's the struct right there. Why wouldn't that be on the stack? I'll have Shy Hat raid you. Does Shy Hat usually stream on Thursdays? I'm usually doing stuff like recording videos or something on Thursday now. And before that, I was just really busy. So unfortunately, I don't even remember Shy Hat's streaming schedule. Think so? Okay. That'd be cool. I do like Shy Hats. Shy Hat usually actually comes in... Shy Hat usually comes in on the Wednesday night streams, though. Let's see. Is it because it's in the heap? Maybe? Hang on, let me go back to the lesson, because I did kind of blow past this part. So one thing about structs is that the member is contiguous in order by declaration. So it is easy to predict how data will be overwritten in memory, even if we found a way to overflow into the struct data. So this example is very similar to the previous one, except for the struct. Notice the structure is global, so it isn't scoped to main. The struct members aren't even on the stack. They're in the BSS. But the buffer overflow will still work the same way. Instead of looking on the stack, you'll need to find the address of the struct in the BSS segment. Okay. Let's see here. Let me see if I can find this real quick. I'm not even sure where to go look at this in here. Let's just run it real quick. Run. What is your name? My name is Betty. Access denied. Your access is 0. All right. So if we look at the source up here, here's our win condition. So to call win, when we enter our name, right, we're going to copy into employee name 40 bytes here. Into from standard in to employee name. Oh, that's actually pretty easy then, because I think what's happening here is the name is only 32 in here. So yeah, we can actually do this. So if we run this and we give it where the crap was that? Here it is. Hang on, we can actually do this like almost the exact same way. We come in here, we send this 80 byte pattern over to it. It should actually work the exact same way, because it tells us what our access number is. Your access level is this. Let's see. We might have to convert that over to hex. No, it's 32 right there. Bam. So now what we can do is, let's do a 32 on there. So now give me a 32 pattern. And what I'm going to do is we're going to copy that. I'm going to run it one more time. So let's go ahead and run this. I'm going to drop this in here, and I'm going to put beep, 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 beep. All right, so let's see. If your structs are an attribute packed, they would be byte aligned. Yeah. I'm trying to think what this is. So, hold on one second. So we need it to be 1337 on here. You didn't say the magic word. Damn it. Oh, so what's it going to read here? Enter your name. So let me copy that. So let's do this. Let's go into our exploit editor. So what we'll do is we want to receive until, enter your name. And then what we're going to send is we're going to send this by 32. And then what we're also going to need is we're going to need we need our target value. So our target value is 0x1337, like that. And then I think we have to little Indian pack that. So what we'll do is we'll say our payload is actually going to be this guy right here. Let's cut that. We'll do payload. We'll do 32. Let's see. We'll do A's. A bytes times 32. In fact, let's do one more. Let's do our offset here in case I screw it up. And then we've got to go fix it. So our offset's going to be 32. And then what we'll do is multiply that by 32. And then we will add in a P32 pack of our target value in here. And then we'll see if this works. Run exploit. No such container. Damn it! Fine, run it on remote. There we go. Damn it. Alright, hang on. Let me copy this. We'll reset it. I think it's going to reload it whenever I reset it here. I love Jurassic Park. I still like Jurassic Park. Sock has seen Jurassic Park 1,000 times, and she still jumps whenever, like, the Velociraptor jumps out. I think she still jumps. Hey, there we go. All right, cool. So that did work. Let's switch to live. Run exploit. Here's our flag. Boom. Almost at the wire. You know what? We did it in good time. There we go. Submit. Actually, I need to do like the Final Fantasy VII sound. I had to click this about 30 times to get it to finally accept it. Yeah, this is all in the browser, man. And I think they did a pretty good job for it. Some minor bugs aside, I love this. This is amazing. If I ever get like chill out time, unlikely, then I'll probably keep messing with this because I really do like it. Binary exploitation, though, is really hard to do on stream. It's just a lot of people, they start seeing those binary bits flying, and it's really hard to track for. I can't even do a 24-hour stream because my flight leaves in less than 24 hours, Gumby. Final Fantasy VII victories. Okay, you know what? Let's see. I'll put it on the list. FF7 victory. I've been meaning to add a soundboard onto the stream deck anyway. So I'll just go set that up. 12-hour stream. My flight leaves in less than 12 hours. All right. Let's see if anybody's over on InfoSec streams real quick. Let's see. Hey, CyberDoc is on. I hadn't seen him online in a while. What's he working on? Let's go see. What's he doing? We're back. How long's he been on? He just got on, so that's perfect. Okay. What's my favorite number? Seven. Mother's maiden name? Miss. Street I grew up on. Concrete. Actually, I'll tell y'all something. I'll leave y'all with really one more funny thing. Let me set the rate up for CyberDoc real quick, since he's on here. But yeah, we were. And by the way, be cool to CyberDoc. He is just kind of getting started, and he's learning cybersecurity. Let me go find him real quick. Let's see. But yeah, so my next door neighbor when I was a kid, like really young kid growing up, she had a son who's a couple years older than me, but we were good friends and we would go hang out together and constantly playing in the street. And she was always yelling at us to get out of the street. And there had been cracks in the road, right? And they'd come and put the tar in them and stuff. And she told me, it's like, you see those black lines in the pavement? I was like, yes, ma'am. She's like, that's the blood of little children that got run over by cars. Ah! So I didn't play in the street after that. There we go. Okay. Got the rate up. All right, guys. Y'all have a fantastic week coming up. We've got, yeah, it's pretty hardcore. She was an awesome lady. I love her, even to this day. All right, guys. I got to wrap it up there. I got to go take care of stuff. I got to finish recording a YouTube video. Y'all have a fantastic week. I will catch y'all Thursday night for the news. And then, by the way, do me a favor, when you get over to CyberDoc, show him some love. He's just, like I said, getting started into cybersecurity. Would give him some encouragement, and also drop a bunch of Hack the Planets and Happy Hackers there in his stream. I will catch up with y'all Thursday night. You guys were awesome. I like the binary exploitation, but I think we'll probably lay off it. Next weekend, we'll do some other shenanigans. And I want y'all to remember one thing. Very important. This is very important. Pay attention. It's going to be on the test. Yes, no backbreaking hats. Very important. This will be on the test. I love you. Peace.